Hello, welcome to Chem Past Papers. This is IGCSE Chemistry, Paper 4, Variant 2, February March 2023. This is Part 2, covering question 4 and 5. Let's continue. Question 4. Copper is element 29 in the periodic table. Brass contains copper. Name the other metal in brass. So the name of the other metal in brass is zinc. So zinc plus copper will give us brass. State the term given to a mixture of a metal with another element. The term is alloy. Alloy is a metal mixture. So you have copper and zinc to give you brass as a metal mixture. So the term given to a mixture of metal with other element is alloy. Next question. Copper can be stretched into wires. Copper wires conduct electricity. Name the property of metals, which means that they can be stretched into wires. The properties of metals, which means that they can be stretched into wires, is ductility. Name the particles responsible for the conduction of electricity in solid copper. The particle responsible for the conduction of electricity in solid copper is electrons. Next question. Copper is a transition element. Some physical and chemical properties of transition elements are shown. Physical properties: high density, high strength. In chemical properties: form colored compounds, have ions with variable oxidation numbers. State one other physical property of transition element. So please take note that the order is pole. That means you are supposed to mention another property that is not mentioned here. So you are not supposed to mention high density and high strength. So the answer is going to be high melting point. Next question, state one other chemical property of transition element. So same thing, we are mentioning another property apart from the two that has been mentioned. Other chemical property is they act as catalyst. Next question, hydrated copper 2 sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. State the term given to water molecules present in hydrated crystals. So the term given to water molecules present in hydrated crystal is water of crystallization. State the color of hydrated copper 2 sulfate crystals. The color is blue. Write the formula of hydrated copper 2 sulfate. So this is the formula of hydrated copper 2 sulfate. You need to memorize this formula for hydrated copper 2 sulfate and hydrated cobalt 2 chloride. It's important that you know the color change when they are hydrated and when they are anhydrous. Next question. Copper 2 oxide is formed when copper 2 nitrate is heated. Look at it. State the class of oxide to which copper 2 oxide belongs to. So copper 2 oxide, it is oxide of a metal, which is copper, and oxygen. And copper of metal and oxygen, which is metal oxide, they are basic oxide. And oxides of non-metal are acidic oxide. So basic oxide react with acid to form salt and water. Next question. State the meaning of the Roman numeral 2 in the name copper 2 oxide. So the Roman numeral simply means the oxidation number of copper is +2. Next question. 0.0200 moles of copper nitrate is heated. Calculate the mass of 0.0200 moles of copper nitrate. So we are given the number of moles. We are asked to calculate the mass. Remember your formula. Number of moles, which is N, is equal to mass, which is M, divided by molar mass, which is mm. So that means our mass, if we make mass subject to formula, is going to be equal to number of moles multiplied by molar mass. Our number of moles is given to us as 0.0200. So what we need to find is the molar mass of copper nitrate. In order to get the molar mass, we add the relative atomic mass of all the elements in the compound, just like we calculate the relative formula mass. So you check the periodic table. What is the mass number of copper? Copper has a mass number of 64. How many coppers do we have in the formula? We have only one, so it's going to be 64 plus nitrogen is 14. And check your periodic table to confirm that. And we have 2 of it. Look at it, this bracket. These 2 outside means that we multiply everything in this bracket by 2. So we have 2 nitrogen, and the mass number of nitrogen is 14. Look at it. It's going to be 14 times 2, which is 28. And plus oxygen. Our oxygen is 16. So we have 3 of it inside. That is 16 multiplied by 3, which is equal to 48. But that's not all. These 2 you want to multiply by it also. So it's going to be 48 multiplied by 2, which will give us 96. So you add up everything. So this will be equal to 488. So our mass therefore will be equal to number of moles 0.0200 multiplied by the molar mass, which is 188. So this will now be equal to 3.76 grams. Next question. Calculate the total volume of gas in DMQ at RTP produced when 0.0200 moles of copper nitrate is heated. We are told that the gas is at RTP and we are asked to calculate the total volume of the gas. So volume of gas in DMQ, let's give it V, will be equal to the number of moles multiplied by 24. The volume of gas occupied at room temperature and pressure is 24 DMQ. So therefore, what is our number of moles? Here we are given the number of moles of copper nitrate, not the number of moles of the gas. So we go back to the equation of the reaction. If you look at the gases here, we have two of them. So we use our mole ratio to get the actual number of moles of the gas given up. So the mole ratio of copper nitrate to this gas is going to be 2 ratio. So we have 4 nitrogen oxide and 1 oxygen, making it 5. And 0.0200 will be ratio n. N be our number of moles. You can use x if you want to. So next is to cross multiply. And when you cross multiply, it's going to be 0.0200 multiplied by 5, which is equal to 2n. And then you divide both sides by 2. So when you cross multiply, this is going to be equal to 0.0200 multiplied by 5, which is equal to 0.1. And 2 multiplied by n is going to give you 2n. So what we do is divide both sides by 2. So you do 0.1 divided by 2 is going to give us 0.05. Now multiply by 24. So therefore, the volume of gas occupied at RTP is going to be 1.20. Next question. Powdered aluminium reduces copper 2 oxide. Write the symbol equation for this reaction. So it's very simple. Like I always say, just write the formulas and you're good to go. So we have powdered aluminium. So what we are interested in is aluminium. What is the symbol of aluminium? It's Al. Reduces copper 2 oxide. So that is plus. What is the formula of copper 2 oxide? The formula of copper 2 oxide is CuO. How do we arrive at this formula? You can just follow the name, copper 2 oxide. So that means our copper, the oxidation state is 2. And then of course, we already know that our oxygen is minus 2. How do we know that? It's in group 6. It needs 2 electrons to complete the shell. So the valency is minus 2. So when you swap, these 2 will come here and these 2 will come here. So what you're going to have is, so next is simplify it by dividing through with 2, which is going to give you this. Further, aluminium reduces copper 2 oxide. The product you are going to get is aluminium oxide plus copper. So you don't leave your answer like this. You have to balance the equation. So we have 2 aluminium here. So we are writing 2. Then our oxygen is 3. So we write 3 here. If you write 3 here, copper becomes 3. So we also write 3 here. So this is the complete symbol equation for the reaction. Question 5. Propane, propene, propan-1-ol, and propanoic acid are members of different homologous series. Molecules of these substances contain 3 carbon atoms. Explain why members of a homologous series have similar chemical properties. It's because they have the same functional group. The functional group is what gives them their chemical properties. Since they have the same functional group, they're going to have similar chemical properties. Next question. Name the homologous series to which propanoic acid belongs to. The answer is carboxylic acid. Next question. State the general formula of the homologous series to which propanoic acid belongs to. So we are asked to write the general formula of carboxylic acid. General formula is CnH2n plus 1 COOH. That's the general formula for the carboxylic acid homologous series. Next question. Propan-1-ol has an unbranched isomer. Name this isomer. So isomers have the same molecular formula but different structural formula. Another isomer of propan-1-ol will be propan-2-ol. That will be the isomer. Next, draw the display formula of this isomer. So we are simply asked to draw the display formula of propan-2-ol. How do we do that? Propan, that means it has 3 carbon atoms. So we draw the 3 carbon atoms. Next, 2-ol, that means it's an alcohol, and the alcohol is on carbon number 2. So if we count, this is carbon number 1, this is carbon number 2, this is carbon number 3. So that means the alcohol functional group is going to be on this carbon. So next, you write your hydrogens. So this is the display formula of the isomer, which is propan-2-ol. The OH is on carbon number 2. Next question. Propane and propene can be manufactured by heating the chain in the presence of a catalyst. One other product is formed. Complete the equation for this reaction. So already we are told that on heating, propane and propene are going to be manufactured. So that means two of the products are propane and propene. So this is going to be for propane, that alkane, and the general formula is CnH2n plus 2. So propane has 3 carbon atoms. So therefore, the molecular formula is going to be C3, H will be 2 times 3, 6 plus 2, 8. The next one is propene, double bond, and the formula is CnH2n. So this is going to be C3H6. So this is for propane and propene. So we are asked to get the next one. So how do we do that? We subtract the number of carbon and hydrogen here from this, that is decane, since the three of them are as a result of the composition of decane. So that means that we have to subtract the number of atoms from it. So we have 3 carbon here, 3 carbon making 6. So 10 minus 6 is 4. This is going to be C4. And next, hydrogen. We have 8 hydrogen and 6 hydrogen. So 8 plus 6 is 14. So when you do 22 minus 14, it's going to give you 8. So this is the equation for this reaction. By the time you calculate, you count the number of carbon atoms and hydrogen, and the reactant is supposed to give you C10H22. Next question. Name this manufacturing process. The name of the process is cracking. Next question. Propene forms a polymer named polypropene. Draw the display formula of a section of polypropene showing 3 repeat units. So we're supposed to draw 3 repeat units of polypropene. So from the name, it's a propene. So that means it's going to be, so this is one of the repeat units. We're asked to write 3 of it. How did I arrive at this? Remember, it is polypropene. That means it's made from propene. Now propene has having 3 carbon. We have, and since it's a propene, double bond is going to be on either here or here, so you can choose anyone. So let's say it is here. So remember that the polymerization takes place at the double bond. So that means this double bond that will break, and then we join many monomers. So when this double bond breaks open, for this carbon, we have another carbon on it, CH3. Look at it here, and of course hydrogen. The second one, there's no any other except the 2 hydrogen. So this is how you draw the repeat unit. So we're asked to write it 3 times. That means I'm supposed to repeat this thing 3 times. So this is going to be, so this is the 3 repeat unit. This is 1, 2, and then 3. Next question. State the type of polymerization that occurs when propene forms polypropene. So the answer is addition polymerization. Next question. Propanoic acid reacts with aqueous sodium carbonate to form a salt. Suggest the name of the salt form. So the name of the salt form is going to be sodium propanoid. Now this is simple. It's just your normal acid plus carbonate to give you salt, water, and carbon dioxide. Just like when you have sodium carbonate and sulfuric acid, it's going to give you sodium sulfate. It's the same thing here. So we're having sodium carbonate and propanoic acid. So the salt that will be formed is sodium propanoid. So just the formula of the anion in this salt. So the anion is going to be the propanoid because sodium is a metal, so it's going to be cation. So therefore, the formula is going to be, our propane is 3 carbon. So this is the formula of the anion in the salt. Next question. Propanoic acid forms an ester when it reacts with ethanol in the presence of a catalyst. So just a suitable catalyst. The suitable catalyst is going to be an acid, especially you can write phosphoric acid. Next question. Name the ester form. So in order to name our ester, we start by naming the alcohol and then the propanoic acid. The alcohol will change to YL, which is alkyl. The ethanoic acid will change to ATE. Okay. So the name of ester is going to be ethyl propanoid. Next question. Draw the display formula of this ester. We have to draw the display formula of ethyl propanoid. How do we do that? We are drawing the display formula. We start with carboxylic acid before the alcohol. So our propanoic acid is, so this is propanoic acid. So let's draw the alcohol, which is ethanol. So when it's forming ester is a condensation reaction. So this OH and this hydrogen will combine to form water. So therefore, display formula of the ester is going to be, so this is our carboxylic acid without the OH. So it will be bonded to this oxygen, which is bonded to this carbon. So bring this carbon first, and then this carbon and the 3 hydrogen. So this is the display formula of the ester form, which is ethyl propanoid. That brings us to the end of this paper. I'll see you in the next one. Don't forget to like, share, and subscribe.